In this class, I will be telling you briefly about three properties of liquid state. The first property is vapor pressure. A liquid always tends to evaporate. Thus, when a liquid is taken in a vessel and the vessel is closed with a lid, then molecules which are present at the surface of the liquid tend to undergo evaporation. But since the vessel is closed with a lid, the molecules cannot escape out. So, they will strike the lid of the vessel and they will condense. Thus, when a liquid is taken in a closed vessel, two processes take place simultaneously: evaporation and condensation. Initially, evaporation is more and condensation is less, but in course of time, evaporation goes on decreasing and condensation goes on increasing. There comes a stage when a rate of evaporation is equal to a rate of condensation. The pressure of the vapors over the liquid at that stage is called vapor pressure. When a liquid is heated in an open vessel, the liquid vaporizes from the surface. The temperature at which vapor pressure of the liquid becomes equal to the external atmospheric pressure is that stage where vaporization can occur throughout the bulk of the liquid and the vapors can expand freely into the surroundings. This condition of free vaporization throughout the liquid is called boiling. The temperature at which vapor pressure of the liquid is equal to the external pressure is called the boiling point of the liquid at that pressure. If the pressure is measured in atmosphere, that is at 1 atmosphere, the boiling point is called normal boiling point. And if the pressure is 1 bar, then the boiling point is called standard boiling point. The second property is surface tension. In a liquid, the molecules which are present on the surface have more energy compared to those molecules which are present in the interior of the liquid. Thus, surface tension is defined as the force acting per unit length on the surface of the liquid. The magnitude of surface tension of a liquid depends upon the attractive forces between the molecules. When the attractive forces are large, surface tension is also large. Increase in temperature increases the kinetic energy of the molecule and thus surface tension decreases as temperature is increased. There are many applications of surface tension. Liquids assume the shape of the container because of surface tension. Second, when small drops of mercury fall, they form spherical beads instead of spreading on the surface. Third, particles of soil at the bottom of the river remain separated, but they stick together when they are taken out. The last property is viscosity. Viscosity is a measure of resistance to flow which arises due to internal friction between layers of the fluid as they slip past one another when a liquid flows. Strong intermolecular forces between the molecules hold them together and resist movement of layers past one another. That is, when a liquid flows over a fixed surface, layer of molecules in the immediate contact of the surface is stationary. The velocity of the upper layer increases as the distance of the upper layer from the fixed layer increases. A force is needed to maintain the flow of layers. This force F is proportional to A, where A is the area of contact. Also, this force F is proportional to du by dz, where du by dz is called velocity gradient. Finally, F is equal to eta du by dz A, where eta is called coefficient of viscosity. The topic which I am going to take now is molecular speed. It is given as a supplementary material towards the end of your textbook. If a given sample has n number of molecules where individual molecules have speed u1, u2, u3, etc., then average speed of the molecule u average is given as u1 plus u2 plus etc. divided by un. Maxwell and Boltzmann showed that distribution of molecular speed depends on temperature and molecular mass of the gas. The above graph shows molecular speed at two different temperatures. From the graph, it is clear that number of molecules possessing very high and very low speed is very small. The maximum in the curve represents speed possessed by maximum number of molecules. This speed is called most probable speed or UMP. It is very close to the average speed of the molecules. As I told you earlier, average speed is given by UAV. Speed distribution also depends upon the mass of the molecules. At the same temperature, gas molecules with higher mass have slower speed than lighter gas molecules. Kinetic energy is given by half mu square, where u is the speed of the molecules. Let us modify this equation into Ke is equal to half mu bar square, where u bar square is equal to u1 square plus u2 square plus divided by n. Then you have another term URMS, where RMS is root mean square. So URMS is equal to square root of u bar square. Thus, in this section, you should know the definition of four terms: average speed UAV, most probable speed UMP, mean square speed u bar square, root mean square speed URMS. The relation is URMS is greater than UAV is greater than UMP.